Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 6, Section 2, Part 3. Today we are going to finish off the rest of the periodic table. So we're looking at the P block elements. And when we're looking at the P block elements, one of the first ones I want you to know is going to be boron and the boron family in group 13. So everyone in this family has 3 valence electrons, 3 electrons in their outer shell. And so they will form +3 ions because they will want to get rid of those 3 to have a full outer shell in the one below. So this is like a mixed group. It has metalloids, which are boron, and metals, which are aluminum. And then the other ones you don't need to know are gallium, indium, thallium, and nihonium. So let's talk about boron. Boron, with its atomic symbol of B, is found in borax, which is usually you can find it in the grocery store, Walmart, and it is used in laundry detergent, like it as a laundry detergent booster. Boron is also used in glass and ceramics. And then aluminum you're very familiar with. It is the most abundant metal in Earth's crust, actually. And it is used in aluminum foil, in cans, aluminum cans, transportation, like in cars, and a lot in construction. Okay, moving on to the next column over, the carbon family, or group 14. And they will have 4 valence electrons. So now we're right in the middle. So they could lose 4 electrons and become +4, or they could gain 4 electrons and become a -4 ion. And they are also a mixed group. They consist of nonmetals, which carbon is a nonmetal. They consist of metalloids. So silicon is a metalloid, and also is germanium. I won't make you memorize that one. And then also metals. Tin and lead are in the carbon family. And also flerovium is in the carbon family. So let's jump into some of those that I want you to know more about and to memorize. Carbon, its atomic symbol is C. So life is carbon-based. We could not live without carbon. Carbon makes up your biological molecules. Those 4 biological molecules, carbohydrates, lipids, proteins, and nucleic acids, are all based in carbon. They're all hydrocarbon based. Silicon is another one of the elements in the carbon family, just below carbon. Atomic symbol Si. It's important as a semiconductor, which are used in electronics. And there were a lot of tech companies in California in this one area, and then they use a lot of computers. They use silicon in a lot of computers because it's a semiconductor. It helps with the circuits. And so they called this area of California Silicon Valley. And tin, Sn, stanius, is used to make bronze. And bronze is an alloy with tin and copper. Then below tin is lead, plumbum, Pb. And this is another biotoxin. So it will bioaccumulate, and it is not good for you. So it has many uses, like ammunition, but it would be better if we didn't use it for things and it didn't accumulate in the environment. And then we have our carbon, nitrogen, and oxygen. So this is the carbon family, which we just talked about, the nitrogen family, and the oxygen family. And these 3 on top are extra special elements, because they can form lots of different compounds that are biologically important. So kind of what is going on there, they have, carbon has 4 valence electrons, and nitrogen has 1, 2, 3, 4, 5, and oxygen has 6. And they are very flexible in who they can bond with and which bonds they can make. So carbon usually shares, and then nitrogen and oxygen usually either nitrogen will share and oxygen will either share or accept. electrons, and they can make lots of different compounds. So let's take a look at some. Carbon is so flexible it can bond with itself in graphite, like perhaps a pencil that you're writing with, or if that is under pressure, then it can form a diamond. It forms a lot of carbon compounds. Sugar and methane are just two examples of thousands of different carbon compounds. And nitrogen forms, here are some inorganic ones, nitrous oxide and ammonia, but nitrogen is found in your nucleic acids like DNA and RNA and in proteins. And then you can see oxygen is found in a lot of these elements, or compounds, excuse me. All right, going to group 15, the nitrogen family. So these are going to have 5 valence electrons. And now we've shifted the tide. It's easier to gain electrons than to get rid of ours. So instead of giving away 5 valence electrons, we want to gain 3. So if we gain 3 electrons, we're going to form -3 ions. This is also a mixed group. You have your nonmetals like nitrogen and phosphorus, your metalloids, arsenic and antimony, and then your metals, bismuth and muscovium. So nitrogen, atomic symbol N, one of the big things it does for us is it makes up the majority of Earth's atmosphere. Like 80% of the air we breathe is actually nitrogen, not oxygen. Oxygen only makes up, I don't know the exact amount, but maybe 15%, 16%. So nitrogen is important in organic compounds like proteins and nucleic acids, like we talked about, and also inorganic compounds as well, like ammonia, which there was a picture of, and dinitrogen oxide, also known as laughing gas. Phosphorus is another one that I want you to know. Its atomic symbol is P. It's important in biological compounds like DNA, RNA, ATP, and your phospholipids. So you cannot live without phosphorus. Also, phosphorus is found in detergents and matches. So I did check on it, and our atmosphere is 78% nitrogen and then 21% oxygen, which is a good segue to group 16, which we call the oxygen family. So these are going to have 6 valence electrons, and it's way easier to gain 2 electrons than to lose 6. So they're going to gain 2 electrons, which makes them a -2 ion. Again, a mixed group. You've got your nonmetals, which are oxygen and sulfur, and then selenium, which you don't need to memorize, and your metalloids, tellurium, I think, and polonium, and your metals, livermorium. So oxygen, I would say, is the most important element in this family. Atomic symbol O, it is the most abundant element in Earth's crust, and it makes up water. So a lot of metals are oxides. And then obviously H2O is in a lot of things. So it is needed for animal life, it is needed for plant life, it's just needed for life, and it is used quite a bit in industry. Also, it is a diatomic gas. So like I said, it's a diatomic gas, which means it bonds with itself, O2. So more about the oxygen family. Moving down from oxygen is sulfur, the atomic symbol S. And sulfur is used in oil refining and mineral mining. So it's important in those industries. So sulfur oxides, unfortunately, when we are using them in industries or actually just refining the contents that are in the earth that have that bonded, it can cause acid rain, which doesn't go well. Hydrogen sulfide is a compound that smells like rotten eggs. And fun fact, solid sulfur was known as brimstone, as in fire and brimstone. Okay, let's move to group 17, our halogens. So group 17, the halogens have 7 valence electrons, And again, it would be a lot easier to gain 1 electron to get 8 than to lose 7. So they are going to form -1 ions. And then we should know that they are extremely reactive. They really, 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 really want that 8th electron, and they will do most anything to get that. They are all in different states of matter, solids, liquids, and gases at room temperature, but they are all non-metals. The first one we're going to talk about at the top of the halogen column is fluorine, atomic symbol F. So fluoride, the ion, is used in toothpaste, actually also in uranium enrichment for nuclear fuel and in refrigerants. So chlorine, you know that you use the compound and the ion quite a bit. It's found in table salt, and it's found in hydrochloric acid, and you can use chlorine to disinfect, like in bleach, or to kill things in a pool. But chlorine by itself is a diatomic gas, Cl2, which would be a yellow poisonous gas, and that was mustard gas that was used in World War I, and it is dead poisonous. It's deadly. You do have it in ion form in your body. And like I said, it forms a diatomic gas, Cl2. It bonds with itself. Bromine is a brown liquid that evaporates into a brown gas, and you can find it used in flame retardants to make things fireproof. It is also a diatomic element. It forms Br2. Iodine, you need iodine in your body for your thyroid to function, for your thyroid hormones. Also, we've used this in biology to test for starch. Iodine is used in industry, and it's also used as a disinfectant. It has like a yellow-brown color, so you probably used it as a disinfectant before. And this is also a diatomic element. It will form I2. It will bond with itself. Question for you is, why does group 17 form -1 ions? Well, if you look here, both fluorine and bromine, which are both halogens, have 7 electrons in their outer shell as their valence electrons. So what they would like to do is really just gain that 1 more electron, and that will make them happy, and they'll have 8. Okay, so let's look a little bit more at our halogens. So we've got chlorine gas and table salt. In pure form, halogens form diatomic molecules, Cl2, F2, Br2, and I2. They are highly reactive and toxic to many organisms. However, halogens will combine with a metal and make an ionic compound or a salt. And the one we're most familiar with is the metal sodium combining with the halogen chlorine to make sodium chloride, NaCl, table salt. All right, let's move to our last column, the noble gases. They have 8 valence electrons. They do not react, and they do not form ions. They are perfectly happy as they are. They are all nonmetals, and as the name suggests, they are all gases. So let's talk about some of them. Helium, atomic symbol He, is the second most abundant element in the universe. Not as common on Earth as it is in the universe, but that is what it is. It is used in helium balloons, and it is used to cool superconductor magnets for MRI scanners. So it's important in medicine as well. Then we have neon, which is used in neon lights. Argon is actually the 3rd most common gas in air, and it is used in welding. And there's neon being used in a neon light. So the elements in group 18 are called noble gases because they do not chemically bond with any of their other elements. Well, why not? Well, because they have full valence electrons, and they don't need anybody to get a full shell. Okay, well, we're running out of time here, so I'll probably just put up the notes I need you to write down, and then we'll talk about it in class. please write the 2 black bullets. Thank you.